Right, so today we're going to look at the radical substitution mechanism. You'll need to know what homolytic fission is and what a radical is before you start this tutorial. So radical substitution is the process by which an alkane, such as methane, can react with a halogen, like bromine, and form a halogenoalkane, like bromomethane, and the hydrogen halide. Now this has to happen either in the presence of UV light or 300 degrees C. The reason for this is because the first step, or the initiation step, is that we need to break the halogen-halogen bond. So the UV light has enough energy to break that bond and form a bromine radical. This is a species with an unpaired electron. Now that radical is what's going to feed into our next step to continue the reaction. Step 2 is the propagation. So that bromine radical that we formed before can react with a methane molecule, and it will rip off that hydrogen, forming a methyl radical and our hydrogen bromide. Now that methyl radical can then bump into another halogen molecule or bromine molecule, and that forms our bromomethane and another bromine radical. So as you can see, we've formed our bromomethane. We've also formed another bromine radical, which can feed back into the first stage of this propagation. That's why it's called propagation. It will carry on going. We're reforming that radical. Right, so then we move on to our final step, the termination step. In this step, two radicals will bump into each other or react together and form a molecule. So we could have two bromine radicals forming a bromine molecule. A methyl radical and a bromine radical could form bromomethane. And a methyl radical could bump into another methyl radical, forming ethane. Now these aren't the only steps. There's a lot of stuff going on in this reaction mixture. All sorts of termination steps can occur, and that's why you can end up with a massive mixture of products. This reaction forms a mixture of products that doesn't just form the products that we want.